Hello friends, welcome to another tutorial which is pretty interesting and important from the point of view of pattern recognition tasks. We are going to study k-mean clustering and k-mean algorithm for uh, data clustering or data segmentation or classification jobs. Now please understand, k-mean is a very popular technique of segregating data points in the feature space, and it's an unsupervised machine learning technique. I'll tell you in a minute what does it mean, and it works on the concept of placing centroids and then fine-tuning those centroids to find the minimum Euclidean distance. Now that all might seem just gibberish to you at this point in time, but once we solve a few numericals using k-mean technique, then everything will be clear. So first things first, we'll see the definition of clustering before we can start anything. It's the classification of objects into different groups, and those groups are known as clusters, so as to say. And now these groups are made so that each of these clusters, they should share some common traits, and now that is often done. These grouping is often done according to some distance measure. Now there are many distance measures. You could have Euclidean distance, you could have Manhattan distance, then maximum norm, Mahalanobis distance, and inner product space, Hamming distance, and so on and so forth. But the k-mean clustering technique will form clusters on the data points in the feature space based upon the Euclidean distance. So these are the few key points that we need to remember before we can proceed on to solve numericals using this k-mean algorithm. Now we'll go step by step. Before we do any numerical, I'll first wish to illustrate the problem that we have in hand. So for example, we have this could be the marks of the students. There are a few students in the class, they've gotten marks in a test, let us say out of 30, and a few students have gotten very few marks and some of them have gotten good marks. Now this is just one parameter or one variable, which is very easy to plot on one axis. Please understand, when we have just one variable to inspect, it is easy to plot. It can be plotted on one axis, and I've done that already. So I've made a simple axis with numbers ranging from 0, which is the origin, to 30, and I've made the data points which are encircled according to the marks obtained by these students. These are, by the way, 9 students who have gotten marks. So having said that, just looking at the data points, can you cluster them into groups, or can you cluster them into 2 or 3 clusters? Now in k-mean clustering, the first thing that we need to address is how many clusters do we wish to make. So this is the first question that we need to answer, and this entirely depends upon the situation, what you wish to achieve from the data interpretation. And then let us say in k-mean algorithm, I wish to segregate this data into 2 clusters. Then k depicts the number of clusters. So if I substitute k is equal to 2, that would mean that I wish to divide this data into two parts. Now my eyes, or just by looking at this feature space of one axis, I would have separated this data into two parts like this. Now the reason or the rationale behind that would have been these guys have gotten lesser marks and these guys have gotten higher marks. They are located at the higher spectrum of the marks and they are located at the lower spectrum of the marks. But my decision is supervised by the it is supervised by what I'm inspecting, which is marks. So I would say that I've kept a threshold of 15 as my decision making criteria, and below 15 I've put them into a different cluster, and above 15 I've put them into a different cluster. So that is supervised machine learning. But k-mean clustering algorithm will not do that. It simply looks the data points without any bias. It does not know that these are the marks of the student. It would just see that these are some data points on a line where the first data point is located at 2 and the last data point is located at 3, and it will cluster these data points into two groups based upon the distance between the data elements. So the closely placed data elements to each other will have similar properties that k-mean clustering algorithm would think. So it has a unsupervised machine learning attitude, and that is what is needed to be understood as a key point here. And similarly, the data makes more sense and the data mining becomes more difficult when the number of variables increase. So if these are the individuals and they've gotten marks in two different subjects, I can plot it on a feature space which is two-dimensional now. So if you look at this feature space, you could see that variable 1 is this and variable 2 is this. So I've made these data points as black dots. So k-mean algorithm will just look at these dots. It has got nothing to do with what dot is associated with which individual. So removing all these labels from the dots, the k-mean algorithm, if it was ordered to divide or segregate this feature space into two clusters, it would have segregated into this and this maybe, or we really don't know as of now as to how it will segregate these data points into two parts, and we really don't know how it will segregate these data points into two parts. And if we order it to divide this entire feature space and the data points in this space into three parts, how will it divide? Our logical sense says that it should divide it into like two parts like this and three parts, maybe keeping 4 as a third cluster. But let's see how it does that by placing the centroids among the data points and then finding the minimum Euclidean distance from the data point, which is, by the way, the algorithm which I'll illustrate step by step now. So let's look at this simple scenario of one axis first in this video, and I'll take up the second numerical in the next video, and in the third video I'll be illustrating k-mean algorithm using some animations which will make the things even more interesting and clearer. Now the first step for clustering a data is to assume these centroids or the means, and that happens by randomly assuming. So this is step number 1. So we assume any two centroids or means on our feature space. So I've assumed first centroid to be here on 4 here. So I'll mark it using a different color. So let us say my first centroid is here and my second centroid is 12. So 10, 11, 12. So this is my second centroid. Now one cluster will belong to centroid 1 and the other cluster will belong to centroid 2. Now this is our own random choice where we want to put these two centroids, but this algorithm is iterative in nature. By doing a few steps it will automatically adjust itself to find the appropriate final value. And how do we put the data points into clusters? Now this is what needs to be understood. Once we select the centroid or the mean as 4, we'll start inspecting the distance of the data points from the centroid, from both the centroids, and the least distance to a centroid will make that data point eligible to be a part of that cluster. Now that is pretty confusing statement, but I'll make it easier by saying that distance of 2 to centroid 1 is 2, because 4 minus 2 is 2, and distance of 2 to centroid 2 is 10. So where will 2 fall, in cluster 1 or in cluster 2? So it'll go into cluster 1, because the distance of 2 from the centroid 1 is smaller than the distance of 2 from the centroid 2. So 2 goes here because its distance is small when we consider centroid 1, which is 4, and 3 is closer to 4 than to 12, so 3 goes here. 4 is closer to 4, the distance is 0, so 4 goes here. Now 10 is closer to 12, the distance is just 2 away from this centroid. However, 10 is pretty far away from this centroid, which is at 4, so the distance is 6 here and the distance is 2 here. So 12 goes into the cluster with the centroid 12, and so on. 20 also goes, 10 goes into cluster 2, 11 also goes into cluster 2, 12, 20, 25 and 30, they all go into cluster 2 because these data points lie nearer to 12. So the first iteration will only place these 3 data points into cluster 1 and all the rest of them into cluster 2. Now this has happened at first iteration. Now in step number 2, what we need to do is we need to shift the centroid based upon the mean of the data points in cluster 1. So cluster 1 has 3 data points, so finding mean is easy. You can simply say that it is 2 plus 3 plus 4 divided by 3. So the new mean becomes 3, 9 by 3 is 3, and over here it becomes 10 plus 11 plus 12 plus 20 plus 25 plus 30 divided by 6, so it becomes 18. So now my centroids have shifted to 3 and 18. So let me mark those again. In the second iteration, my first centroid has shifted to 3. So it has gone here. I'll put this. And my next centroid has gone to 18. So this is 12 and this is 18. So now you'll see some data points will shift their positions in terms of their participation in the clusters. So K1 cluster, now we know that 2 is nearer to 3, so it goes here, 3 is nearer to 3, 4 is nearer to 3, and 10 also becomes nearer to 3 because the distance is 7, and if the distance from 18 is 8 and 11 goes here in the other cluster, so cluster 2 gets 11, 12, 20, 25 and 30. So again we calculate the mean in step number 3, which is the third iteration. We get M1 is equal to 4.75 or roughly 5, and M2 is equivalent to 19.6, which is 20. So we add up all these, divide by 5, add up all these, divide by 4. Now when we say the centroid has shifted again to 5, so the new centroid has gone here at 5 and it has gone to 20. So 20 is here. So let's see where the data points will fall now. In cluster 1, which has a centroid at 5 approximately, we'll see that 2, 3, 4, 10, 11, 12, all of them will be nearer to 5, and only 20, 25 and 30 would be nearer to 20. And in step number 4, which is the next iteration, we again find the mean M1 is 7 and M2 to be equivalent to 25. Adding up and dividing by 3, adding up and dividing by 6 will give me 7 and 25. And now you'll see that K1 remains the same. So the centroids will not shift its value in the next iteration. So if this becomes a stable value, so the centroid will not shift, because when we add up all these and divide by 6, when we add up all this divide by 6, we will get M7, M2, 25. So the centroid will not shift from this point onward, and that is how we find that the cluster 1 is composed of these data points and cluster 2 is composed of these data points. Now incidentally, if you look at this feature space, initially even our eyes were inspecting the same thing. We were also segregating these 6 data points as one cluster and these 3 data points as the other cluster. So K-mean algorithm is pretty logical in terms of placing the data elements which are similar in traits to each other in one cluster, as a normal human being would interpret by his or her naked eyes by looking at the data sets in the feature space. And similarly we'll see how the K-mean algorithm with Euclidean distance performs this clustering in the next tutorial. And I hope you liked this tutorial. I'll see you in the next one. Keep watching. Have a great day ahead. Bye.